Hi everybody, I'm Sean McSorley, Sales Manager for Europe at Hoymiles. Thanks for joining us today. We've collected some questions from our customers ahead of today's events, and we're also joined by Eric, our Solutions Engineer at Hoymiles, to explore and answer
Hello,
them
everyone.
together. Welcome, Eric. How are you?
Thank
Okay?
you. Yeah, good. And
Good to
nice to
see you.
meet you, everyone.
Yeah, nice to see everyone. Welcome to HoyTalk, a new conversation series by Hoymiles. Here we connect with our customers, exchange ideas, and explore new possibilities for the future of energy. HoyTalk, conversations that move energy forward. This is the very first edition of HoyTalk, and today's session is all about powering the whole home. As residential energy storage continues to gain momentum across markets such as Europe and Australia, homeowners are looking for more than simply storing more energy. Increasingly, they want reliable and seamless backup power when extreme weather or grid outages occur. However, for both installers and homeowners, traditional backup power solutions often mean additional equipment, more complex wiring, and modifications to the existing electrical panel. In residential settings, where space is limited and installation costs are a major consideration, these challenges can create significant burdens for both installers and homeowners. So how can we deliver reliable, flexible, and easy to install whole home backup power without adding complexity to the home? And looking ahead, how can we further connect energy storage, intelligent energy management, and EV charging to meet the growing energy needs of households? Based on these real-world needs, Hoymiles has introduced an all-in-one home energy solution featuring HiSwitch and HiBox. The solution rethinks home backup across grid to off-grid switching, system expansion, installation, and maintenance, while integrating with the HiOne home energy storage system and V2X charging system to deliver a more reliable, intelligent, and flexible home energy ecosystem. So, Eric, let's get into the topic and start with a big picture, shall we?
Yeah, sure.
Okay, so the first question that we've had from many of our customers, and what does a one-stop residential energy solution consist of, and how do the different components work together?
Sure. Maybe we can start from the core of the solution. Here you can see the basic HiOne system architecture. At the center, we have HiOne integrating the inverter and battery system. The PV system connects into HiOne directly, and the home can also integrate our V2X DC charger. So even at this basic level, we are already bringing together PV generation, battery storage, household consumption, and EV charging. But of course, a complete residential energy solution is not only about storing energy. Homeowners also need backup power, energy monitoring, and different levels of system control. That is why we provide different architecture around the HiOne platform. Here you can see the system is expanded with HiBox. HiBox is placed between the grid, HiOne, and the house loads, forming the whole home backup architecture. And on this page, you can also see that the system can connect additional elements such as generator, smart loads, and a microinverter, and so on. So HiBox is designed for applications where the energy architecture becomes more complex. You can also see the Hoymiles cloud here. The complete system is connected to the user app, installer app, and also the O&M web platform. So we are not only integrating the power devices, we are also bringing monitoring and system management into the same ecosystem. And in this page shows the alternative architecture using the HiSwitch. Here, the HiSwitch provides the backup switching architecture in a much more compact form. The system can support both partial backup and whole home backup, depending on how the loads are connected. So at a high level, we have two gateway options. HiSwitch is focused on a simpler and more compact backup architecture. HiBox provides more flexibility for more complex energy scenarios. We will look at both in more details during the discussion, I believe. So if we summarize here the complete solution, HiOne is the core energy storage platform. HiBox or HiSwitch provides the backup architecture. and V2X connects the EV. HiMiles provides the digital management layer. So together they form the one-stop residential energy solution. Sean.
That's great, Eric. That's a great overview of how it all fits together. Let's zoom in on one scenario homeowners really care about, a power outage. For homeowners, the key question during a power outage is, will my appliances keep running? So when the grid goes down, how does the system switch to backup power and keep appliances running without interruption? So this is where I'm assuming we can dig more into the HiSwitch and the HiBox. But yeah, great.
Yes, thanks. And this is actually one of the most important use cases for residential storage. When the grid is operating normally, HiOne works together with the grid PV and the home loads. But when a grid interruption occurs, the backup gateway, either the HiBox or HiSwitch, as we introduced before, switches the system from on-grid operation to backup operation. HiOne can continue supplying the home using the energy stored in the battery and available PV power. So the key number on this page is smaller than 10 milliseconds. HiOne together with HiBox or HiSwitch can provide a smaller than 10 millisecond backup transition. And the examples on the slide show why this matters. A very short interruption may already restart Wi-Fi equipment, right? And a longer interruption can restart a TV. And once the interruption reaches around 1 second, the household appliances may completely shut down. So with a seamless backup transition, the goal is that the household appliances simply keep working. For example, the refrigerator keeps running, the lights stay on, and ideally the homeowner doesn't really even notice that the grid has disappeared. So from the user's perspective, backup should not feel like another complicated operating mode. It should simply happen automatically. Grid goes down, the system switches, and the home keep running. Yeah, Sean.
That's great, Eric. Great. That's really reassuring for anyone who's been through an outage. Another question that we hear from installers, just as often as homeowners, is that whole home backup sounds ideal, but what about installation complexity and cost? How does Hoymiles make backup easier and more affordable to install?
Yeah, this is exactly the installation pain point that HiSwitch is designed to address. If we look at the conventional backup installation, several different electrical components may be required. On this page, left-hand side, you can see the main functions: the meter, circuit breaker, transfer switch, bypass switch, and CT. With HiSwitch, all 5 are integrated into one device. That's why we call it a 5-in-1 design. And another very practical advantage is the installation format. HiSwitch uses a DIN rail concept. So instead of adding another large wall-mounted backup box, it can be integrated much more naturally into the electrical installation, for example, in the local home distribution panel. This is especially important in the retrofit projects. Very often, wall space is already limited and the installer wants to avoid unnecessary rework. The page also shows a significant space-saving advantage compared with a conventional backup switch. So HiSwitch is really designed around the simple question: how do we add backup functionality while creating as little extra installation work as possible? And also the next challenge is the cabling, as separated backup solution normally creates additional cable connections, especially around the APS side of the system. With HiSwitch, the integrated architecture eliminates the extra APS cable shown here and simplifies the overall connection. So for installers, this means fewer cable routes and fewer connection points. And this matters for both time and cost, of course. Every additional cable means installation time and cost, and every additional connection point also creates another, maybe an opportunity for wiring mistakes. So reducing wiring complexity helps make the installation faster and more repeatable. And the same philosophy also applies to HiOne itself, not only the backup function. The battery modules use a cable-free stackable design. The installers aligns and stacks the modules without internal battery wiring. And for cable connection, HiOne uses spring terminals and pluggable accessories. And for commissioning, the system supports automatic device detection, key feature configuration, automatic testing, and network configuration. For example, during the commissioning, if the CT direction or the phase sequence is incorrect, the system can detect the issues and correct it automatically. This helps reduce configuration errors and saves additional troubleshooting time on site. So overall, we simplify the installation process into 3 main steps: 5 minutes for pack connection, 5 minutes for cable connection, and 5 minutes for smart commissioning. This gives us the concept of a 15-minute installation under suitable site conditions. And we are still working to make the commissioning process even simpler. So when we look at this complete installation, the HiSwitch simplifies the backup side, and HiOne simplifies the ESS side. Okay, Sean.
Yeah, that's great to hear that it's practical for installers, Eric, and we've had very good feedback from many installers now about the speed of installing the HiOne and our other solution. And then seeing the HiSwitch added to the portfolio is great, because we're obviously giving different options there dependent on the scenario. So yeah, it's very good to see. And as we know, installers want quick installation, commissioning, time's money, move on to the next project, etc. And that's what we want to do, create efficiency throughout our product range. But Eric, systems do sometimes need attention after they're installed. So what happens if the backup system itself needs maintenance or components fail? Can homeowners keep their power supply? Because that's obviously a concern from wiring into a backup system, loads, etc. So yeah, if you could go through how the customer would still have power if there was any issues with the backup system.
Yeah, definitely. Maintenance is another area where the backup architecture needs to be very practical. So this page shows the manual bypass function available with both HiBox and HiSwitch. So when the inverter or other system equipment requires a service, the bypass function allows the installer to isolate the relevant part of the system. That makes the fault isolation and maintenance more convenient. And importantly, the purpose of the bypass architecture is to help keep the household loads supplied while service is being performed, as you mentioned, also where the system condition allows. So the installers does not have to treat the complete home electrical system as one single block. And HiSwitch itself is also designed with serviceability in mind. The page shows 2 important points. First, HiSwitch is designed for repeated high current switching with up to 6,000 high current, 10,000 high current switching cycles. And second, HiSwitch is a standalone replaceable module. So if the HiSwitch itself is damaged, the installer does not need to replace the complete ESS. The inverter and the battery can remain in place. They will not be impacted by the EPS failure. Only the HiSwitch needs to be replaced. And that reduces the number of components that need to be disconnected and reconnected. And it can, of course, significantly reduce the after-sales work. So integration does not mean the complete system becomes one large non-serviceable unit. We will keep the critical switching component independently replaceable. Okay, Sean. I hope I answer your question.
Yeah. I mean, it's good to know that homeowners aren't left without power. If there is any problems, I think that's the main question. So with the switchover that we have, that's fantastic. Thanks for explaining. So this move on to another question, another topic, Eric, that we receive from a lot of our customers, and that's talk about the savings, because it's usually top of customers' mind too. I know people install solar systems for many different reasons. You know, some might be more environmental, some might just want to be more, you know, off the grid themselves. But obviously, in many markets, there's different situations for saving money. So today, homeowners really want to know more than just the backup power. They also expect their energy storage system to help lower their electricity costs. How does this system help them achieve greater energy savings, Eric?
Exactly. That's why we introduced the AI functionality into the residential energy storage system. So backup is of course important when the grid goes down, but most days the grid is working normally. So the system also needs to create value for the homeowner every day. HiOne provides the AI mode for smart energy scheduling. As shown here on the left-hand side, the AI mode combines information such as dynamic electricity tariff, solar generation forecasts, and household energy usage patterns. Based on these inputs, the system can optimize charging and discharging behavior automatically. So, for example, with a dynamic tariff, the system can charge when electricity prices are lower and discharge when prices are higher. At the same time, it can forecast future energy generation and consumption instead of only reacting to the current moment. The page also shows two saving indicators, up to 50% reduction in peak tariff time and up to 18% additional electricity bill saving. Actually, the actual savings, of course, depend on the household and local tariff conditions. But the idea is to move energy use toward the most economic time. And there is also another AI function shown on this page on the right-hand side, the AI for service. The idea is that users can get answers to energy-related questions through the AI home energy agent instead of always waiting for traditional service support. So AI is used both for energy optimization and for improving the user experience. And when we talk about smarter energy use, actually HiBox also gives the system another layer of flexibility. The smart port allows selected loads to be connected for intelligent load control. This helps the system put more available clean energy to the home, to work into the home. And this page also shows that HiBox can support the addition of a second inverter, and it can connect additional power sources such as generator, third-party PV inverters, etc. So in more advanced applications, energy optimization is not limited to only one battery and one inverter. HiBox can become the control center, connecting multiple energy sources and flexible loads. Yeah, Sean.
Yeah, that's great, Eric. I mean, the numbers are compelling when it comes to obviously saving on cost of energy, storing energy, you know, and the whole ecosystem. And as we know, we're always integrating and working increasingly to integrate with dynamic tariff providers, energy companies, etc. So, you know, and the AI functionality delivers a very good package for, you know, making the system super intelligent and, you know, forecasting how the homeowner might be using energy, etc. So that is great. But then looking ahead, you know, because needs change as households grow, as household energy needs grow over time, how can the system be scaled up without replacing the existing equipment, Eric?
Yeah, that is also a good question. And this is another important design principle of HiOne as well. A residential energy system may operate for many years, and the household's energy demand can change significantly during that time. So HiOne is designed to provide flexibility from the beginning. On this page, you can see some of the main system highlights. We have 4 MPPTs for independent PV power tracking. The system supports high PV input current, and on the battery side, the architecture can reach up to 64 kilowatt hours under a single inverter. So already at the basic product level, the system is designed to cover a wide range of residential requirements. Expansion is important, but the system still needs to, of course, remain practical to install. So this page focuses on the physical design. HiOne integrates the inverter, battery, and EMS in one compact architecture, reducing the wall space compared with separated components. The battery modules are also designed to be lighter and slimmer, which helps the installers carry, lift, and position them on site. All wiring is hidden behind the side, so the final installation also remains clean. So scalability does not have to mean a large and messy installation. And this page shows the actual expansion flexibility in more detail. One inverter can support up to 8 battery packs. So that means up to 64 kilowatt hours of battery capacity. The battery uses built-in parallel DC-DC functionality, allowing the system capacity to be expanded later, no matter what you need. So homeowners can start with the capacity they need today and add more capacity as their requirements grow. The 4 independent MPPTs also give installers flexibility for different roof orientations and PV layouts, so the system can adapt both on the battery side and on the PV side. And if the project needs to grow beyond one inverter, the HiBox page we saw earlier shows that a second inverter can also be added, right? But for pure on-grid system without gateway, up to 10 units of inverters can be connected in parallel. And as more energy assets become connected to the home, I think safety remains the foundation. This page shows the 6-layer battery protection concept. It includes elements such as pressure relief, fire safety module, cell level monitoring, thermal barriers, and multiple temperature monitoring points. The purpose is to provide protection at several levels, from the individual cell up to the battery module. And design is one thing, right? But validation is another. So, but our HiOne system has also gone through extensive environmental testing. The slide shows high temperature, low temperature, rapid temperature change, and damp heat test conditions. So the reliability of the platform is designed to support long-term operation under different environmental conditions. Yeah, Sean, back to you.
Yes, fantastic, Eric. You know, with so homeowners can grow into the system rather than replace it, which is a very strong selling point. You know, as energy requirements grow, you can add new battery modules. The DC to DC converter can help with that, and all the BMS, you know, built-in BMS in each battery module, and all the safety. Thanks for running through the safety side, because you know that is core of Hoymiles products is safety, and also to see the extreme testing that the product has been through is fantastic. So thank you very much for that. Last question, and it's one that is going to matter more to EVs and the EV market itself. You know, as we're seeing lots more and more EV cars coming into different countries, and yeah, so I think for the EV owners, they really want to understand, how can an electric vehicle become part of a home energy system, Eric? And how does this integration work? Because obviously we've got a large battery sitting potentially right next to our house, that we're connecting to charge, etc., through our solar system, or from the grid. But yeah, it's there's a lot of energy there. Although you've explained clearly how with the HiOne we can add storage later, which is great, and this might be one of the reasons to do so. Someone might decide to move to an EV car, and they want more storage. So yeah, if you could sort of tell us more about how that's looking, and what a Hoymiles we've now launched for that scenario.
Yes, yes, of course. EV is becoming a alternative mobility compared to the traditional petrol car. But beyond that, actually, EV is where the home energy ecosystem extends beyond the house itself as well. So traditionally, the EV is simply another electrical load, but you come home, connect the car, and consume electricity. But with the V2X, we want the EV to become part of the energy system. This page first focuses on installation flexibility. The V2X charger is a standalone device, so it can be installed conveniently beside the parking space. HiOne can remain in the location that is best suited for the battery system, so they can be separated. And that gives the installer much more freedom in the site design. And the page also shows that one HiOne inverter can support the simultaneous connection and charging of up to 2 EVs. So this architecture is also designed for a household with more than one electric vehicle in the future. The next part is how the user manage EV charging. The V2X charger is integrated into the same app environment. The homeowner can choose different charging modes. In green power mode, surplus PV power is prioritized for EV charging. In faster charging mode, PV, grid, and battery power can work together to provide maximum charging capability. So the user can also set charging schedules, monitor changing status, and control charging remotely. So the vehicle is no longer managed as a completely separate energy devices. Its charging behavior becomes part of the overall household energy strategy. And now we come to the main value of the V2X. It is not only about charging the EV, it's about a bidirectional energy flow. With the V2X, energy can flow not only from the home to the vehicle, but also from the vehicle back to the home. So the EV battery can become an additional backup energy source when the grid is unavailable. As shown here, an EV battery can provide a very significant amount of stored energy. For example, with most of the car in the market, around 100 kilowatt hours can be provided as a backup power during the grid outage. Another advantage is the charging speed. Our V2X DC charger supports up to 22 kilowatt of charging power. Compared with a traditional AC charger, this can add significantly more driving range within the same charging time because the charging power is not limited by the vehicle's onboard charger anymore. And that brings us to the third advantage, the energy path itself. With a traditional AC coupled charging architecture, the charging process relies on the vehicle's onboard charger, or we always call it OBC. That means the energy goes through an additional conversion stage before reaching the EV battery. With our DC-coupled V2X architecture, we bypass the vehicle's OBC, onboard charger, and connect more directly to the battery on the DC side. This means fewer conversion stages, lower conversion losses, and of course, more efficient bidirectional energy flow. Okay, so if we now come back to the complete product overview, this page brings the major building blocks together. We have the inverter and the integrated EMS. We have the modular battery system with a capacity range shown here. And we all have the gateway layer providing backup switching, either HiBox or HiSwitch. And we have the V2X DC charger for EV integration. This is the hardware function behind all of the use cases we discussed today. So HiOne is not designed as one insulated product. It is the core of a broader residential energy solution. Thank you, Sean.
Thanks, Eric. And I must mention on that side as well that the products look very nice. We've nice color, very good aesthetics. So when everything's combined in the household, it's a very nice looking system as well. So that's great. Oh, thank you very much, Eric. That's a great note to bring us towards a close. But before we go, I just want to say a huge thank you to everyone who has joined us today. We really appreciate you spending this time with us on our first HoyTalk. At Hoymiles, everything we do comes back to one simple idea: open energy for all. We believe every home, every business, and every community around the world should have access to smart, reliable, renewable energy. And that's what drives us, because we know how much a difference that makes in the fight against climate change. Quality is never something we compromise on. Our products are built to the highest standards, and a huge part of our company is dedicated purely to R&D. Because we're never satisfied with where the technology is today, we're always working to push it forward. Hoymiles isn't just providing backup power. We're building a complete home energy ecosystem, as you can see from the current slide. But I do want to mention some of our other products, because we produce microinverters from a single microinverter capable of multiple modular inputs, including simple DIY solutions, hybrid inverters, and full battery energy storage systems, single phase to three phase, all the way through to commercial, industrial, and utility scale products. It's all part of one mission: open energy for all, giving homes and businesses everywhere access to smart, reliable, renewable energy. Built on quality, our R&D team never stops improving. To learn more about our energy solutions, follow us on LinkedIn and YouTube, or visit our official website. We look forward to seeing you on the next HoyTalk, so please keep an eye out for that. Thank you very much for joining, and see you on the next talk.
Thank you.
Thanks, Eric. Thanks for your support. Have a great day, and we'll see you all soon. Thank you.
Have a great day. See you.
Bye-bye.